Okay, now let's look at this question where it says to prove a to the power n minus b to the power n is divisible by a minus b. We try to see how does the binomial expansion looks like. Okay. So we can always expand a plus b to the power n and see how it looks like. But we try with 1 plus x to the power n, which is first term is 1 and second term is x, sorry, nx, then n into n minus 1 x square by 2 to n factorial by n factorial, basically ncn, right? So n factorial by n factorial into 0 factorial x to the power of n, basically 1 into x to the power of n. So here what we see is all these terms are, all these are, what do you see? All have x, okay, in them. So this thing can be written as 1 plus x to the power n minus 1. I bring 1 on the left side, equal to x into all these terms, right? So I can say that x is a multiple of, sorry, x is a divisor of this, or I can say this is a multiple of x. So 1 plus x to the power n minus 1 can be written as 1 to the power n equal to x into. Now if you look at the question, we have something similar. This is similar to a to the power n minus b to the power n, and it's x into something, a minus b into something, then a to the power n minus b to the power n is divisible by a minus b, right? So what we have, we can replace x is equal to a minus b, because that's what we have right here. So if x is equal to a minus b, right, what will be this 1 to the power n? If we put 1 equal to b, and our 1 plus x will be 1 means b plus x means a minus b, which is a, right? So basically it's a to the power n minus b to the power n equal to a minus b into all the terms. This means a to the power n minus b to the power n is a multiple of a minus b. What we have done here is we can do in a little different way. So a can be written as, sorry, what was our 1 plus x? 1 plus x was a, right? So a can be written as a minus b, basically b plus a minus b. Okay, a can be written as b plus a minus b. Now if we, so a to the power n can be written as b plus a minus b to the power n. Now when we expand it, what are we getting? Our first term will be b to the power n. Second term will be nc1 b to the power n minus 1 a minus b to the power 1 plus nc2 b to the power n minus 2 into a minus b to the power 2. So basically we'll have something here, then a minus b to the power 2. Then again we'll have something a minus b to the power cube. Then we'll have some constant, and then we'll have a minus b to the power 4, all the way up to a minus b to the power n, right? So this whole thing, I can take a minus b out, and it can be written as a to the power n equal to b to the power n plus a minus b sometimes. Means a to the power n minus b to the power n is equal to a minus b into something. So this proves that a to the power n minus b to the power n is divisible by a minus b. Okay. Let's look at the second way to prove it. Prove by induction. So induction means you first prove for a base case, which is where n is equal to 1. Then you assume that it's true for k. True for n is equal to k. And assuming it's true for n is equal to k, you prove for n is equal to k plus 1. So we take the base case. When n is equal to 1, our a to the power n minus b to the power n is equal to a to the power 1 minus b to the power 1 is equal to a minus b. And a minus b is divisible by a minus b, right? So for n is equal to 1, this is correct. Now let's assume it's true for n is equal to k. So we have a to the power k minus b to the power k. Since we have assumed it's true for n is equal to k, that means a to the power, this part I can write it as some constant a minus b into something. Let that something be p. Okay. This is what we have assumed. This line means a to the power k minus b to the power k is a multiple of a minus b. Okay, multiple means where p is a natural number, right? So we have assumed this. We have to prove it exists for, it's true for k plus 1 as well. So a to the power k plus 1 minus b to the power k plus 1 is equal to a into a to the power k minus b into b to the power k, right? So this can be written as e to a to the power k minus b. So I can write b to the power k as a to the power k plus, if I bring this on the left side, so b to the power k is a to the power k minus a minus b into p. Okay, so it's a into a to the power k. I expand, multiply and expand this into b into a to the power k and plus b p a minus b. This can be written as a, I can take a to the power k common here. So a to the power k is a minus b plus bp a minus b, which is I take a minus b as common. So a minus b into a to the power k plus bp. So my we started with this term here, which is a to the power k plus 1 minus b to the power k plus 1. And what we have now is a minus b into some terms. That means this is a multiple of a minus b, which means this thing is a multiple of a minus b. This is what we had to prove. Okay. Okay, let's look at this greatest coefficient. So I have given two questions on the greatest coefficient, then try to find some pattern. So what we'll do, we'll try to find some pattern first, and then we will solve 1 and 2. Okay. Okay, so let's write the binomial expansion. A plus b to the power n is equal to summation of r ranges from 0 to n in c r a to the power n minus r b to the power r. Correct? So my tr plus 1 will be n c r a to the power n minus r b to the power r. What is my tr plus 2? R is equal to 0 means first term. So r plus 1 means r plus, if it's r here, it means it's r plus 1 term. N c r plus 1 a to the power n minus r plus 1 b to the power r. Okay. Now what we do? We do tr plus 1 divided by tr plus 2, just to see what do we get. Okay. So to simplify, this can be written as n factorial divided by r factorial into n minus r factorial into the a to the power n minus r and b to the power r. Similarly, this thing can be written as n factorial r plus 1 factorial. And this is n minus r plus 1 factorial. So n minus r plus 1. So n minus r minus 1 factorial into a to the power n minus r minus 1 b to the power, sorry, b to the power r plus 1. So b to the power r plus 1. Okay, so when we divide it, what do we get? This n and n will cancel out, right? R plus 1 factorial will go up in the numerator, and this r factorial, r plus 1 will go into numerator, r will stay in the denominator. So r plus 1 factorial by r factorial will be r plus 1. Now we have n minus r. So we solve this. So it's similar to n minus r minus 1 divided by n minus r. Which is bigger? The denominator is bigger, right? So we can write it as n minus r minus 1 factorial by n minus r into n minus r minus 1 factorial. So this thing will cancel out. We'll have in the denominator n minus r left into, now we solve for a and b. On the numerator, we have a to the power n minus r. Denominator, we have a to the power n minus r minus 1. So in the numerator, we'll have a left, and in the denominator, we'll have b left. So it's a by b. Okay. So this is what we get. Right. Now we look at this r plus 1 by n minus r. If this number is greater than 1, That means TR plus 1 is bigger than TR plus 2. Right? Like 6 by 5 is greater than 1. That means 6 is greater than 5. So if R plus 1 by n minus R is greater than 1, that means it came from TR plus 1, right? So Rth term is greater than R plus 1 term. Okay. Or we can do other way around as well. If it's less than 1, then it will be other way around. Okay. So in the binomial theorem, what happens is the coefficient will start somewhere, it will increase, then it will decrease, or it will always increase till the last term. These are the only two possibilities. Okay. Of course, we can rearrange a plus b in such a way that it increases and decreases instead of like decreases and increases. Okay. So if you didn't understand this part, increase part or decrease part, we take a quick example. If we have 1 plus 100x to the power 5, what we'll get here? We'll get 1 plus 5 into 100x plus 5 into 4 by 2 into 100 square x square. Right? It will go till 100 square, 100 to the power 5x to the power 5. So if you look at the coefficient, we have 1, then we have 500 from here, then we'll have much bigger number, 800 into 100 is 10,000. Okay, so somewhere 10,000 into 20 by 2 is it 10. So it's like a 100,000, and it will keep on increasing because the power of 100 is keep on increasing. But if we write this as 100x plus 1 to the power 5, we will get reverse order, where the first term will be very big, 100 to the power 5 something. The second term will coefficient be 100 to the power in the range of 100 to the power 4 and all the way down to 1. So it's either increasing or decreasing. But we can always rearrange in such a way that the coefficient always increases. Same thing for this. This one will be observed when now we can always replace. We started with 1 plus 100x to the power 5, right? What if this 100 is not 100, some fraction, like less than 1, 1 plus 2 by 3, kind of thing, x to the power 5. This is okay. If we try to expand this, the coefficient will first increase or decrease depending on how we rearrange it. So now we look at our question. What it says, find the, let's look at the second one. This first, 1 plus 10x to the power 5. 1 plus 10x to the power 5. So as we have seen, in the first term will be 1. Second term will have 10 to the power 2. Third term will have 10 to the power 3. Fourth term will have 10 to the power 4 and 10 to the power 5. So we can see that the greatest coefficient will be in the last term, right? Because it's like monotonically increasing. So we can directly write the last term as NCN a to the power 0, which is 1 to the power 0, 1, and 10x to the power 5. NCN is 1, so it will be 10 to the power 5, which is 100k. Basically 100k x to the power 5. This is my term, which will have the greatest coefficient. What was my second question? 2 plus 3x to the power 11. 2 plus 3x to the power 11. Okay, so we don't know which term is greater. So I do TR plus 1 divided by TR plus 2. Like we have binomial, when we expand it, we will get like term 1, then term 2, right? Then term 3, term 4. What I'm doing here is all the way to term 11. R plus 1 by R plus 2. So I'm just dividing, example, if R we take as 2, it's like T3 plus T4. So I'm just dividing the consecutive term, 3 by 4 or 4 by 5 or 5 by 6. But currently we don't know what my R is. Okay. So I'm just using the generic term to divide. We already calculated this is equal to R plus 1 by N minus R into A minus B. R plus 1 by A minus B. Sorry. Uh, into A by B. R plus 1 by N minus R. Sorry. R plus 1 by N minus R. So here my R is, we have to calculate R. So I leave at R plus 1. N is what? 11 minus R into A by B. So A is 2 and B is 3, right? Because I'm interested in coefficient, I can ignore X. And this, if I put greater than 1, we can is 2R plus 2 is greater than 33 minus 3R. If I bring it here, is like 5R greater than 33 by 2. Sorry, 33, not 33 by 2. 33 minus 2, which is 31. So R should be greater than 31 by 5, which is 6 point something. Okay, 6 point. So R has to be greater than 6.2. That means R is equal to 7, right? Because it's only an integer. If R is equal to 7, that means in our expansion, what was R? In our expansion, it was NCR, A to the power N minus R and B to the power R. So this R has to be greater than 6. R has to be at least 7. So when we put R is equal to 7, we have 11C 7 A. A is our 2 to the power 11 minus 7. B is our 3x to the power 7. So this is our greatest coefficient. Okay, it is 11 factorial by 7 factorial into 4 factorial into 2 to the power 11 minus 7 is 4 into 3 to the power 7. This is my greatest coefficient.